Hello, today we're going to be going over how to use the regression function in the Desmos online graphing calculator. In class, we already covered how to do it on the TI-84, so hopefully you can practice that, but sometimes the Desmos is a little bit easier to use, especially because you can type with a keyboard instead of having to press all the buttons on the calculator. So we're given an example dataset, and the first thing we're going to do is click on this Add Item button on the top left. You're going to get a drop down, and we're going to go to Table. And now we're just going to copy the table that we're given, all these coordinates, and just put them in here. So let's start with the left side. Go to -4, -2, 0, 1, 2, 3, 4. And then we'll move on to the right side. Apologies. And as you can see, we already populated points just by making that table, and they all map to the points that we have on the left. So now let's go ahead and hide that image. And just looking at this, it looks relatively linear. So we're going to use a linear regression. To do that, all you got to do, on the left side of the screen, click Add Regression. We're going to set linear regression, and it automatically does it for you. We can check to make sure that that is the correct line just by going y equals 1.82256x plus 0.0165414. And they're the same line. It matches up pretty well. We're given pretty accurate R2 value. You want that as close to 1 as possible. So let's move on to our next example. So example 2. We're given another data set, and we're going to do the same thing. Those of you that are really good at pattern recognition and already have all of your functions down might already know what this function is. You might know the exact equation of the function even. To me, it's kind of U-shaped, right? So we're going to go and do a quadratic regression. So you're going to do the same thing. Click on the left where it says Add Regression. And instead of having linear regression, because if you look at that line obviously does not match the data set. So we're just going to click linear regression, then go down to quadratic regression. And then we're given our function right here. And you'll notice that that is the same as our quadratic parent function, which is just x squared. It's the same function, and we have an r squared value of 1, which is as close to matching the data set as possible because it's a perfect fit. We're going to move on to our third example. This one is a little more hectic. You might not be able to recognize a pattern right away, so you might have to go through a couple different models. But what I see is we go up from the left, and then we drop down going towards the right, and then go back up. That reminds me of a cubic function. If you remember, our basic cubic function is going to be x to the third. And it looks a little bit like that, a little different, but this is just our parent function. So we're going to go same process as before. Click Add Regression on the left side. Linear regression doesn't match the data too well. Quadratic regression also doesn't match it too great. Cubic regression, it matches it pretty good. We have kind of that same shape, right? And it just, same thing as before, it spits out all your values down here. You can also click just click on the equation, it'll highlight it, Control C to copy, and then you could paste it in. And if we wanted to, we can just hide that function, and that's our function. So you could get all the values that way as well. Let's move on to our next example. Example 4, we're given another data set. This one is definitely a little weird. You might not have seen this function before, but we're going to cover it anyways, just for future reference. So this looks kind of like a wave to me. We're kind of going up and down, and we can assume, just for the context of this problem, that it repeats. So same thing as before. And let's go through and see which functions match this the best. So linear regression, it's kind of similar, but not quite. Quadratic, not really. It kind of looks the same as the linear. Cubic, that matches it pretty well, but let's keep going. Quartic, it looks okay. Kind of the same thing as the cubic though. Exponential, that really does not look right. Logarithmic, it's not even there. Definitely not right. Power regression, it looks okay. Logistic, definitely not right. But we move down to sinusoidal, and that looks like a perfect fit. And we can confirm that with our R2 value down here. That's equal to 1. So perfect fit. And the equation for this, it's just going to be a basic sine wave, but it's going to be shifted and stretched. So we're shifting by pi over 2. Stretching by pi over 2. And moving it to the left by pi. And that looks like a perfect fit to our graph. Don't worry about it if you don't know that function. It's just another example of how our R-squared values work. Let's move on to our final example. Here seems to be just a random set of numbers, but look at that. I'll let you pause the video for a second so you could practice this. And now we'll go into it. Same thing as before. We're going to go press this add regression button, and you'll notice immediately, wow, that's a linear function. And if we look down here, we can copy our function, paste it up there, and now let's hide our points. And what I see from this value right here, don't worry if you don't, but I see pi. Y is equal to pi x plus 1. And that looks like it fits really well, doesn't it? As you move on, as you practice more, you'll be able to spot stuff like this. This is a super basic regression model, just linear, does it all for you. Same thing as the calculator, it's just a lot faster to input your values. I will link to this Desmos sheet below the video. Good luck on your test today.